So up here we have scene, and for volume fog, placeable volume fog to work, first you need an exponential height fog actor in your world. Most of you should have that. It is default inside most blank maps. So this does exist. The actor is hilariously low. Where did the here we go. There. Let's move that up a bit. There we go. So this fog both is affected by the settings that you have here and how dense it is, but also how far up from the world you pull it. You can have it as far down or as far high as you need to get your fog effect to work the way you want. I'm just going to leave it there for now, and I'm going to reset this density volume to default. We'll just kind of make the fog a little dense right now. Tweak the fall off a little. But these are just standard exponential height fog components, and that is just affecting kind of the fog on an overall global scale. You have the ability to add a secondary fog right here, which is kind of, it's just 2.1. So you can have extra fog if you want. That fog can have a separate fall off. You can also offset it, which right now I don't think it's doing too much, so we'll just undo that. And that's really dense, so 0.2. Oh, 0.02, that's what I want. There we go. And both of these fogs can have your color slightly adjusted. There are other settings here. Min and max opacity. You can actually control the start distance, so you can push the fog out further from starting if you want. If you want the fog to cut off, you can adjust this cutoff distance. By default, it's at 0, which means it goes into infinity, but you can cut it off to a specific level if you want the fog to end. Let's see, this is just scattering within the fog. You can apply a texture to it so that the fog looks like it has a bit more of a look to it. And then this is just art direction tweaking. Sometimes they can make a huge difference, sometimes they don't. And as you can see right here, not really doing too much. The volumetric fog needs to be enabled for this placeable fog to work. By default, on exponential height fog, volumetric fog is turned off. You do need to make sure this is turned on. Then you have additional settings here that you can control, like the albedo of your fog. Let's say I want this to be a little warmer in tone. Color picker so I can see it. You can adjust the extinction scale so it maybe is a little foggier overall. And I'll come back to some of these later, but start distance, same deal as the start distance with the fog originally, so whether you want it to start everywhere or you want it to start a certain distance away, and you can kind of see that happening right here. So all that needs to be enabled for any of this to work. I'm going to go ahead and save the scene. Yeah, let's check that out. To build our fog, I'm going to swing over to class prep, even though I don't have it here. And I'm going to create a brand new material. So like much of Unreal, this is driven through the material system. Let's see. Let's call it local fog. And then I'll open the material up. And we will immediately start making a couple of changes. Because this is a fog material, it's not something that we can apply our standard shading elements to. So over on the left under material, we have a number of different options to adjust, and we've adjusted these for decals before. We need to continue to adjust them for our fog, which is going to be a volume. This is going to be something that takes up the interior of a space. Volume makes the most sense that way. And we have to control how it blends. I don't know if we have, yep, we have an error. So it already tells you down here at the bottom, the moment you change it to a volume, that your blend mode has to be changed. And we're going to choose an additive blend mode, so we'll add to the scene. And I'm going to start with that right now. I think those are the two main things that need to be fixed. So once you change that, you'll see that the material options you have got significantly reduced. You're stuck with just albedo, emissive color, extinction, and ambient occlusion for some reason, which we're not going to be using. So albedo is simple enough. I'm going to hold 3, I'm going to add a color, convert it to a parameter. Let's call it fog color. Let's give it something more interesting than black. That'll work. And we'll just plug that in up there. Cool. This is the easiest part. The rest of this isn't necessarily terribly difficult, but it is a little more involved than that. We are going to be working primarily with extinction. So extinction is going to control how this all fades away as our camera disappears from it. And I think the easiest way for me to build this for you all is to start from this chain. We are going to start with the world position node. This node is going to pull the world position of whatever it is attached to, and we are going to pull X, Y, and Z. This node has the ability to change the type of world data on the left that it is pulling from. You can pull absolute world position, that includes material and shader offsets. You can exclude material and shader offsets, or you can get camera relative position, including and excluding those offsets. We are going to roll with absolute world position here. And we're going to take this position, and we are going to not do a transform vector, we're going to do a transform position. Right down here. Oh, cool. So transform position also has options on the left, and some of these more advanced like shadery nodes have options on the left to allow you to change how they work. So currently this is taking local space to absolute world space of the position of whatever the input is. We are going to change this to be more aligned with the input position we have. So we are going to be taking the absolute world space, which is what we are passing through from this node in all directions, and we are going to transform it to local space. So this is going to pull our world position, and then it's going to transform it to be local, so it kind of matches as you think an object might be in terms of its local position and as it relates to itself. It's like when you're changing the gizmo in Maya from world to object, in a sense. This node is then going to get passed into a sphere mask. This utility, as far as I understand it, takes inputs and masks them in the shape of a sphere. That's about as far as my understanding goes. So this is one of those things where I know how to use the node, but I don't know exactly everything that goes on with it. And that is going to be our A input. Our B input is going to be the value of 0. So we will be using a radius and a hardness to kind of mask and blend between these two. Our radius is going to be the bounds of the object that this is applied to. And that is not the one I was thinking of. Okay, no, that function is there. Cool. Let me see if I can find it. Material function. I wonder if there is a plugin I don't have enabled. Should be easy to find though. Engine content. Okay. There we go. Let's see. It should just be in functions. Engine material functions 0, 2. Bounds. This thing? Yeah, that's it. Okay. Cool. So I'm just having to navigate to this because it's not showing up in the material view, but has a material function. I can just drag and drop it. And delete that. So I needed object local bounds. This material function, you can double click to open it and take a look and see exactly what it does. Takes the minimum amount of the local bounds of the object and the maximum value, plugs them into min, max, and then a bound size where it subtracts these two. If you need to know what the bounds of an object are, I can actually show that very easily. I just need to find some sort of model. Sure, this will work. Okay. Give me a second to remember where the pull down for this is. Shockingly, looking for object bounds is not the thing I do all the time. These are the bounds of the object. And these bounds can be adjusted in your object settings. This isn't something you typically do, and it's not something you need to do in this class by any stretch of the imagination. But if you're really trying to optimize for occlusion calling, making sure that as your camera shifts, you're only rendering specific things, shrinking these bound sizes down can actually, bless you, can actually allow you to do that. What our material function is doing is it's pulling the minimum bound, the maximum bound, and it's subtracting in order to get the size of the object, and that is what we are passing through into a divide node. And so we really just need the bounds size for this. And again, this is a material function, so we needed to pull it in from the engine stuff, but everyone has access to that. The engine folder is local to your machine, so everyone has this on their drive. Let's see, that is A, cool. We are going to divide it in half. I don't see any reason why you wouldn't necessarily decide to create a parameter of this. We can test that later. And this will be the radius of our sphere mask. And then hardness is going to be just a singular scalar value. We can in fact just take this hardness value and hopefully promote it to a parameter. And there we go. And default value, in my example, I have 0.5 set, so let's do that. So this is all the math that is setting up our spherical mask, which we are then going to multiply Why would we be multiplying this by 1? Alright, I'm going to promote this to a parameter 2, and we're going to leave it just as b, and the value is 1. That's something I'm going to come back and test. In my further example, again, that one is just a value, and I don't know why. It's been a bit since I used this, whatever tutorial I used to follow this, and it's very entertaining for me to sit here and think and ask questions. So when you follow my examples and you're like, why did Dan do this? Definitely think about that. Maybe sometimes Dan doesn't ask enough questions himself. All right, so this is the mask setup, and we are going to throw this into an additive node. So we're going to be adding it to some other math that's going to control how our extinction works, but we're pretty much done with the sphere mask. So we can take this, make sure I save, just drop that there, and then we'll build the rest of the mask over here. So we're going to need a couple of, actually we'll start with this one. we are going to grab a node called distance to nearest surface, and it does exactly what it says it does. Finds the distance to the nearest surface. We are going to be subtracting. That goes into the B input. A max distance value. From the distance to the nearest surface. And then we are going to be doing a linear blend between the values of 1 and our max distance. Which I'm reading that correctly? Yes. By a value that's going to control how hard the edges are. And I'm just going to go, let's set that to 1 for now. And that is going to be our blend value. We will then be dividing the output of this linear blend between 0 and 1. And the max distance, and the difference between the max distance and the distance to the nearest surface node. We'll be dividing those, and that is going to be what is added into the B input of our addition node. So we're taking this up here, which is just doing math on the distance between surfaces, and the sphere mask we have built up down here at the bottom. We'll be adding them together, and then last but not least, we will be creating our own custom extinction value. Let's see, my value here is 1. Sure, we'll start with 1. And this custom extinction value will go and basically act as a way for us to clamp down and adjust the output of all of this to either be stronger or weaker as needed. So then we can apply that. We can save. I'm going to close our 2 example nodes here. Our content browse back. And let's go ahead and material instance. Demi underscore local fog, yes. And for this to work, we just need to apply it to something. And what's cool with this fog is you can apply it to pretty much anything. So I'm going to swing over here. And let's just add a cube, I guess. Let's make this cube very large. Just drop it right there. And this is one of those cases where you definitely are okay taking this material instance and just dropping it on the asset that you need. And we can see it's working. It started out very strong and then it's settled, and you're getting flickering down here at the bottom. So the fog's already working correctly, but we need to certainly make adjustments so that it's not looking like an error. So we can open up our material instance. Let's just kind of do our little side-by-side and turn everything on. And we can start with things that aren't temporary, like B. So edge hardness we'll leave alone for now. Max distance. Start scrolling that. It will update kind of slow, so just you might need to be aware of that. There we go. And we make that distance a little bigger. So 300? Sure. And then edge hardness. Drop that to 0. Yeah. And then our extinction value. And drop that down a little bit. Which that's quite a bit. Let's do like 0.2. Edge hardness. Well, we kicked it up to 1.5. This is what we currently have. Something like that. And what was the B value that I created? Yes, it was whatever this multiply is. And then I also wanted to test. This makes sense to me. I know why I didn't do that. There's another value I wanted to test. No, maybe it was just that one. Now let's see what B does. Oh, that's neat. Okay. So as I kick B up very high, you can see the actual shape of the sphere mask, even though this is in a box. So B is controlling how much of the sphere mask is shown or that it's applied to. So you can use it as an interesting way to kind of flatten the fog down, actually. I can go pretty low and it flattens the fog, so that's actually interesting. I'm glad I made that a thing. So anyway, I can go ahead and save this. And we now have this placeable art directable volume fog. And this allows you to have local fog effects in areas that aren't just determined by your scene and how your fog is rendering, right? So I could place this here, and if I were to hit play, other than the box having collision, which we can fix in a second, we have ourselves volume fog. If we want to fix the box and be able to run through it, we just select it here, open up our details panel, let's close the content browser. Let's see, physics. Find collision and change its presets from default to no collision. It will only affect that specific box, but now we should be able to run through it. Yay, super foggy. And so you just continue to adjust these values until you get the look and feel that you want. Notice that the values changed as I scaled the box up. When the box was a lot smaller, the values behaved very differently. So that's something you'll want to be very aware of. You'll have to adjust values based on the size of your objects and how you're placing them. Another thing to be aware of is that eventually, if your camera's far enough back, the fog disappears. This is controllable, so I'm going to go, let's go back here. This is controllable on the exponential height fog under volumetrics. Let's see, general. Oh. We have our view distance. Right now it's at 6,000. There we go. This does affect the volumetric view distance of everything, but it will make sure that your fog, your placeable fog volume does render as you extend. Yes. Yeah, it's just all in the settings of the material. Right now it's just set, like I set it to be not so sharp when it was smaller. I scaled it up and I have to go and reset all those values again.
Is there a way to make relative to the player? There's a density where it's set a whole bunch of other.
Relative to the player, meaning that it's constantly a certain amount of density as long as the player's around it, and it.
Yeah, so you can like see the player, but you can't see the player, right? So
that would be math, but there's no reason to think you couldn't do that. Yeah, I just know. Could I do it off the top of my head? Probably not. But it might not be super. It might be easier for you than for me, honestly. I might. Maybe if we have time today, I'll start messing around, seeing if I can make it work.
Well, either way, I think just that exponential fog volume, that's by itself. But I'm not sure. Fog volume like that.
Oh yeah, the placeable fog volume. No, you're right about that. You could probably. Let me look real fast, just to see what node we got available. Let's see. Wrong one. So we need. No, not even close. So in the blueprint, you could easily get the player and get the player's position. You might be able to do it in a blueprint. Yeah, I'm thinking you might be able to do it in a blueprint because you could get the player's position and then probably have different volumes that one renders a denser fog material and then further away it changes to a different fog material and it just follows the player as you run. I mean, just as an example, like I think that would actually not be too hard to do. I could probably make that work in class. It'd be broken as fuck, but it'd work.
Also,
But that may not be the best way to do that.
also, do you know, for the exponential fog volume, if there's a way to get faster certain aggregates to be effective of less fighting?
Not off the top of my head.
I'm asking that question here.
Yeah, well, yeah, you're asking questions that. Because it does that automatically to a degree, because when you have volumetrics enabled, areas that are more enclosed or more low-lying will receive more fog, typically. So the volume itself will do that.
Right.
But if you need it to an extreme degree, probably not. And that's where I would use a local fog like this. Have a very low-level general volumetric setting, and then use placeable fog to highlight the areas where you want it to be like spooky or alien-y or whatever. Yeah. Yes. There are more advanced things you can do with the local volume fog. I can run you through a more dense material on this later, just as like an aside outside of class. Or not outside of class, in class outside of this part of the lecture, because there's a lot more that's going on with it, and most people don't need animating fog, so. Cool. Any other questions? Got the wrong screen right now. Cool. Okay.